All right, so all of this is kind of background information we've already taught in this class in this unit. Okay, it's kind of the stuff you need to know. It's not kind of, it is the stuff you need to know to really understand what we're going to do next. pH in the Arrhenius acid-base theory system is the negative log of the hydrogen ion molar concentration. And it's also the negative log of the hydronium ion molar concentration, and that's in the Bronsted-Lowry system. Molar, when we use that term, means moles of solute divided by liters of solution. We put it in a fraction like this, moles of solute divided by liters of solution, and the symbol we use is M with a line under it. Now when you're printing on a computer, a capital M by itself is sufficient for molarity. Okay? But when you're writing on paper, it's required that you put a line under the M to make sure it's clear that you're using a capital M and not a lowercase m. Just a couple of definitions here. Solute is the thing being dissolved. Solvent, the thing that is doing the dissolving. Solution is both solute and solvent together. So if I have a glass of tea, I've already dissolved some things in the water to make the tea. I've dissolved, I boiled the tea in the water, I put the tea in the hot water, and it's leached out some stuff. Some stuff's being dissolved, including tannic acid and other things. But then if I put sugar in the water to make sweet tea, okay, southern delicacy, sweet tea, ice, sweet tea, right? Okay. The solute then is the thing being dissolved. That's the sugar. That's what you're dissolving in the water. Okay? The solvent is the water. That's what's doing the dissolving of the sugar. And so all of it together, the sugar, the water, the tannic acid, the other things that make tea, that makes up the solution. Okay? Now if you put ice in there to make cold sweet tea, the ice is not part of the solution. The ice is not part of the solution because the ice is not dissolved. It's still in big chunks in there. Okay, now once it dissolves, all of it's mixed up together, then you have a solution of everything, but the ice isn't there.
And you have nasty tea.
Because it's weak, is that what you mean by nasty?
Yes.
Okay. All right. Well, if there's anybody from someplace other than the southern U.S. that's listening to this, they won't have a clue what you're talking about. Okay. Maybe. Yeah. Okay. All right, let's move on. So, we said that pH then is equal to the negative logarithm of the hydrogen ion concentration. We have a special symbol to indicate the concentration, the molar concentration of something. The special symbol we have to indicate the molar concentration of something is to put that something in brackets. That's a negative symbol. Okay? And whenever we say log, that means the word logarithm. And if I don't tell you otherwise, log is always assumed to mean log base 10. Okay, now that's a little beyond what you guys do in math in this class. So really all you got to know is you got to press the logarithm button. Now let me tell you what a logarithm is. A logarithm is an exponent on the number 10. A logarithm with a base 10 is an exponent on the number 10. Okay? So when I put something in brackets like this, this means the molar concentration of X. Okay? Log, or, let's see, gotta make sure I know how to spell it. I think it's this. No, that's an I. Let me double check. Look it up real quick here. Make sure I got it right, so I don't give you a misspelling. I don't ever use the word logarithm. Yeah, I. Log or logarithm is an exponent on the number 10. Okay? So, the log,
Is that a... You mark through that one?
yes, the log of the number 10 with an exponent of 2, the log of the number 10 with the exponent 2 is 2. Get out your calculators and try it for yourself. Logarithm. Log is just a shortened word, shorthand for logarithm. The word is actually logarithm. So everybody got their calculators, and let's do this calculation. You need to practice with your calculator to learn to calculate logarithms, because this is going to be the thing that's going to trip up you on the test. If you use my little inexpensive calculators, you're going to have real trouble with this math. Okay? The less expensive calculators are the hardest to calculate logarithms with. Okay? More expensive calculators make it a little bit easier for you. Okay, now I have several different calculators. I have a TI-84 here. Okay? So I'm going to find the logarithm button on my calculator. It's right here. There's log. I'm going to put in the number 10. I'm going to put an exponent on that 10 of 2. I'll close the parentheses. And I get the number 2. So there's how you can see for yourself. A logarithm is simply an exponent on a 10. Yes? You have a question?
No.
Okay. Huh? If it's just whatever logarithm on 10 is what it is. Now, you get a different number if we use scientific notation, because then you got to take into account the number that's being multiplied by that 10 to some exponent. Okay? All right. So since the logarithm, negative logarithm of the hydrogen ion concentration is the pH, and since the Bronsted-Lowry version of that is hydronium, then it's also true that pH equals the negative logarithm of the hydronium ion concentration. Okay? You may or may not know this. You should know it. That if you add pH and pOH together, you're going to get the number 14. So pH plus pOH. I told you what pOH was when we were doing the first lab in this unit. Okay, it's the flip side, the opposite of pH. This is a scale usually reserved for determining the strength or the concentration of acids, and this is one used for determining the concentration of bases. But when you add those two numbers together, you get the number 14. Negative logarithm of the hydrogen ion concentration. That's what it means. The little letter P right here always means negative logarithm. The little letter P in front of anything means the negative logarithm. Okay? If I write, for example, I'll slip a paper over here that I'm not using right now, just to give you kind of a quick example. If I write pKa, that means the negative logarithm of whatever this is. That happens to be an acid ionization constant, which isn't part of something we do in this class. Okay? But it's very important in medicine if you want to be a nurse. Okay? Yes, that's you. Okay, then you need to know about pKa's. Okay? All right. Because that's part of what's called the Henderson-Hasselbalch equation, which is very important when you're determining whether somebody has the blood pH is right. Or determining what buffers are needed for medicines and things. Okay? All right. Now, this is important. This is important to know. If you know the pH of something, of a solution, then it's really easy to find the pOH. If you know the pH of something, it's really easy to find the pOH. Okay? For example, if the pH of a solution is, let's say, 4.37, what is the pOH? Now this is simple math, guys. Super simple math. How do you find the answer to that?
7 and then hold up, right?
There's your equation right there. Plug the number in. Yes, that's what it comes out to be. All right, so but plug it in this equation first and then move things around to solve for it. Okay? pH, it says is this, plug it in right there, find the pOH. Now I know you did this math in 5th grade because I used to help my sons with it. I don't think so. Yeah, 9.63 is what it comes out to be, okay? All right, so if pH plus pOH equals 14, and this is the pH, then 4.37 plus the pOH equals 14. We've got to isolate the unknown. That's the process we've been using for a month now. To get this by itself, when I have an addition problem, I have to subtract this number from both sides. So we subtract, You're doing that math now? So this gives you a 0 over here for this. So we've isolated pOH. And over here we get 6.63, I think, isn't it? 9.63, I'm sorry, yeah. That's my dyslexia kicking in there. I don't really have dyslexia, I'm just... Okay? So look, guys, finding the pH from the pOH or the pH from the pOH from the pH is super simple. This is not hard, but you have to know this equation. You have to know that equation. Everybody got that? All right, then. Let's move on to something that's a little bit harder. All right, now we said a logarithm is an exponent. So if I know the pH, I can find the molar concentration. Remember that symbol, when you put something in brackets, means molar concentration of what's inside? Okay? If I know the pH, I can find the molar concentration by putting that pH number as a negative exponent. Remember, a logarithm is an exponent, right? We said so here. So, the molar concentration of H plus is equal to 10 to the negative pH. And the molar concentration of the hydronium ion concentration is the same. It's equal to 10 to the negative pH. Not hard. Shouldn't be. Here's our example. All right? All right? You should be able to do this. Get your calculators out and practice. This is the one that's going to trip some of you up because Some of you have the inexpensive calculators, and you're going to have to back into the calculation. If you have the more expensive calculators, you put it in the way it reads. Okay, do you have your calculators out? I don't think you have logarithms on your phone. Well, you think you can do it, but you can't use your cell phone on a test. All right, here's how I put it in my calculator, a little bit more expensive calculator. I need a base of 10. I'm going to use this up caret button right here. Can't see it there. There's an up caret button. All right, to make an exponent, I'm going to put the negative pH in parentheses. So I'm going to hit my change of sign button, and I'm going to put in the pH number 4.37 and close the parentheses. What, the number? Well, if you do it on your calculator, you should have it anyway. Okay? So the molar concentration of the hydronium ion is equal to 10 to the negative pH, which is 10 to the negative 4.37, and that equals 4.265795,188 times 10 to the negative 5. Now, the problem we have here is that exponents or pH numbers don't have units of measurement in them usually. Okay, not at this level anyway. So this is one time where you have to know what the concentration is. You have to know that we're finding the hydronium ion concentration, so this is the molarity of hydronium ions. Okay? Now we have to round it off. There's a special rule for...
So where do you get the negative?
It's part of the number on the calculator. Alright? So we have to round this off. There is a special rule that applies to logarithms and exponents. We're not going to learn a new rounding rule. Okay? What I want you to do is to apply the multiplication and division rounding rule. Okay? So since we started out with 3 digits here, we want to round this to 3 digits. Okay? 1, 2, 3. Underline everything else. Draw an arrow. And your final answer is going to be 4 point what? 27. Because that 5 makes the 6 round up to a 7. Times 10 to the negative 5th molar hydronium ion. Okay? Alright, now, the calculator that you have right now, do you have logarithms on your phone?
Yes.
You do? Were you able to put it in and get that number?
No.
Then don't use your phone. Get a calculator. If you can't get the right number, then don't use your phone.
Well, I didn't really do it because I didn't have enough time and I didn't understand how to work it.
Well, try it. See if you get it. Put it in. Kathy, you have the inexpensive calculator you're using? Yeah. Okay. You're going to have to back into it with the inexpensive calculator.
So where do I put the
Here's what I want you to do, Cassidy. Listen carefully. You have an inexpensive calculator. You're going to put in the exponent first. Put in 4.37.
Negative 4.37?
Put in 4.37. Then find the change of sign button on your calculator. I think on that calculator it says plus / minus or something, doesn't it? And then when you put that in, it'll say negative 4.37, right? All right. Let me think now. And I think then you have a 10 to the exponent x button on there. Do you have that on there somewhere?
I do. I have 4.2657651880.
See what's above logarithm here?
9, 2,
So you're going to
7.
go second log. And you can get that number.
Next, this one, you get the symbol.
Okay, now if you do it the right way, you may get your answer like this, or you may get this answer, 0.0004265,795, or maybe not even that number of digits. Well, if we move the decimal place 1, 2, 3, 4, I'm sorry, I should put an extra 0 in there. 5 places to the right. Okay, then we get the same number we had up here.
So when do we use the log button?
Just be patient. We just did a while ago. Alright, you calculated.
I used the 10x button and I got in.
I understand. Okay. The flip side then is if we know the molar concentration of hydronium, then we can use that log button to find the pH. Okay? Okay? So if the molar concentration is known, then calculating the pH is just a matter of plugging that molar concentration into the equation over here that I gave you earlier. Okay, do that, solve that problem then. Now if you have the inexpensive calculator, this is really hard to do. Okay? Because you probably are going to have to put in 8, change your sign, put that on the base of 10, so that's where you hit that second log to get that number on the 10. Then you multiply it by 3.47. Then you hit the log button. Then you hit the change of sign button. Whereas on a little bit better quality calculator, we just put it in the way it reads. Okay? So this is our molar concentration of hydrogen ions. And so what we need is, since pH is the negative logarithm of the hydrogen ion molar concentration, and that's that number right there, then we're just simply going to find the negative logarithm of 3.47 times 10 to the negative 8 to find the answer. So I want to hit my change of sign button. I'm going to hit my logarithm button. I'm going to put in 3.47. Actually, I can do this double E button to get that, because that means the same thing as 10 times 10 to some power, negative 8. I think you can put it in like that on that calculator. Find your change of sign button. You probably have a negative sign in parentheses on your keyboard. Hit that first.
I've already got the log in my
It's probably, the E is probably sort of right above some other buttons. So you have to hit your second and then that whatever button yours is that has the double E on top of it. Okay? And that just means some number times 10 to some power. That's what that E means. It's a shorthand way of writing scientific notation. Okay? So 3.48 or 3.47 times 10 to the negative 8 is the same thing as this. Okay? So that little E button, double E button or E button on your calculator sure does make the math faster. Okay? You got it?
No, I got a negative version.
Then you didn't do, did you put a negative in front of your logarithm?
I put negative 8.
Did you put a negative in front of the logarithm?
No.
Then that's why you have a positive number, a negative number instead of a positive number. Change the sign.
Let me try again.
Okay?
Just remember how I did it.
Okay? And so we're going to round that off then to 3 digits. And we're going to calculate our pH to be 7.46. Okay?
That's invalid input.
Hmm?
That's invalid input.
Really?
I told you.
Yeah. Get a calculator.
It's down.
Bring it to class. What you're supposed to be doing anyway, right?
I left them my book bag when I took the
All right. I think there are some videos on the website that show you how to use less expensive calculators. Okay, if you need to be able to do that, but it's a much better investment to spend about $12 on a calculator like that one right there. What is a TI-30X? Okay, that's not too bad for a calculator, right? You can spend about $80 or $90 and get a good graphing calculator, or you can spend even more money and get something like a TI Inspire, which is even easier to use.
Which is the SAT.
You can use a TI Inspire.
But it's like a CS.
You can't use. No. I think. It depends on what. AP. Okay. You can use. There are rules for it. I'm not sure about the SAT. It's been a while since I've done anything with that. Okay. Now, so that's.
Is it true that there's
Let's don't go to that right now. Let's go on. Let's stay with this. Okay. All right. Turns out there's something called the auto-ionization constant for water. The auto-ionization constant for water is 1 times 10 to the negative 14. Huh? Okay. Molar squared. Okay. The auto-ionization is equal to whatever is times the hydroxide ion concentration. Right here, that's squared, 2. Okay. So if I know the molar concentration of hydronium, okay, in either one of the last 2 problems we did, I can use this to calculate the molar concentration of the hydroxide, or vice versa. It is freezing on me here.